Let's move on to our final type of t-test in this video. So SPSS has the ability to not only look at how one variable or one mean compares to some sort of an average, predetermined average, as well as looking at mean differences between different groups or different values. It also has the ability to look at a single value or group across time. So for example, we might say, how do test scores for students do before they take some sort of a training course and after they take the training course. So you have a student complete a test, you mark their test, you give them some sort of a training program, and then after they do the program, they retake the test with new questions, and the results are compared between the two. So anytime you add in that before and after with one group, with the same group, that is referred to as a paired samples t-test. So in other words, paired equals the same. Okay, so let's test this out using our case study example. So imagine our company, now that they know that they've sold more units relative to sort of a typical average day of about 140. And now they know that City A has sold fewer units than City B, right? We confirmed that with a negative 4 point whatever t statistic in the last video. Here we want to know, just looking at City A, how did they perform, or how many units did they sell before they offered the event and after they offered the event? And importantly, is the difference between before and after statistically significant? So yes, you can say one number is higher than the other, but is it statistically significantly higher or not? So SPSS has the ability to do that. What we're going to do is go to Analyze. As I've described in the first video on one sample t-test, I always encourage you to go into frequencies and select a histogram and confirm that your data is normally distributed. This is important for parametric tests such as t-tests. Okay, so please refer to that video so that you can see what that process looks like. So in this video, we're going to focus straight on comparing the means using a paired samples t-test. But before you click on that, what is important here in this case? So let me explain. So what is our null hypothesis? Our null hypothesis in this case is there is no difference between City A's after event sales before and after the events took place. The alternate hypothesis is there is a difference in after event sales for City A before and after the event took place. So I tried to emphasize it there, but City A is the only city that we want to run an analysis on. So we're going to do this wrong first. I'm going to show you what it will look like, and then we're going to fix it and do it right after. So click on Paired Samples t-test. For variable 1, this is your before, and variable 2 is your after. So for our before, SPSS will automatically populate it, so you just choose it in chronological order. So sales we want to know before the event, move it over, and sales after the event, and move that over to variable 2. If you need to move things around, you just drag them back, and you can drag them back into the boxes as well. Okay. We'll click on options. We'll make sure that our 95% confidence interval is selected, as well as exclude cases analysis by analysis. I talk about this in my one sample t-test, why it's important to choose these options. Okay, so down here we'll keep estimate effect sizes, and you typically keep this selected standard deviation of the difference. This is a very good way to compare mean differences between before and after context. Okay, so once this is set up, we're going to hit OK. And remember that the results we're going to get are not the results that we want. And I'm going to explain why after we hit OK. So here's our data. So first off, you can confirm that we've made a mistake because n should not be 79. If you recall from the case study, we have a total total observations across all 3 cities of 79. This is an indication here that we are not looking at only one observation. In other words, we're including city A, B, and C in this analysis. And therefore, we're not answering our question. Our question is there a difference between before and after sales events for city A specifically? Okay, so the rest of our data here is related to all 3 cities, and we don't want that to happen. So remember, this is wrong. What we need to do is we need to select just city A data before we run our paired samples t-test. So to do that, you'll go to Data, down to Select Cases, and we're going to select if condition is satisfied. Select if, and here we'll tell SPSS to only run an analysis for city A. And the way to do that is to create a case for it, or sorry, to create a formula for that. So name of city, we'll bring that over to our box. So here we want city, and what we want is we just want city A. Well, do you remember how city A was labeled? That's right, it's city A equals 1. Okay, don't type, just use the option, the boxes here, city equals 1. That way, when we hit continue and OK, now when we run our analysis, paired samples t-test, our analysis will just be filtered for city A, and we'll rerun it, all the same information, right? So we'll rerun that, and now we can confirm that we have it correct because our n is no longer 79, our n is 27. And we can confirm that if we go back to our data view, we can confirm that city 1 has 27 rows, right? So there we go. That confirms that. So let's come back to our results now. And our analysis shows that we have a mean before the event of 143.44 with a standard deviation of 14.270 and a standard error of 2.746. Remember, this standard error is our standard deviation divided by the square root of our population size. Okay, our sales after the event do seem higher, but only 3 units, right? So if we round it, actually 143 versus 147, it goes up by about 4 units. So who knows? Is that just it is a different number, but is it a statistically significant difference? That's what we're using SPSS to tell us. The standard deviation on sales after the event is 14.471 with a 2.785 standard error. So these numbers don't seem too far off from each other, but let's see, we might be surprised. So here we'll look at, first of all, the correlations. Correlations is a valuable check. It doesn't confirm that there's a significant difference, but it does tell us if the two are correlated. So we want to see that before event and after event sales are correlated. And to do that, we simply look at the significance level. We confirm that it is below 0.05, our confidence level of 95%. And because it is, we can conclude that the two comparisons are correlated. In other words, we are allowed to compare before and after event sales. All right, and then here's our main table. This is where we're referring to most importantly is our paired samples t-test. So here we can see that we have a mean of a mean difference of negative 3.444. Remember that these are units, right? So we're going to have to do a bit of rounding. I rounded up to 4, but SPSS has decided, to bring it down to 3 potentially. So just make sure that you're being observant of those differences. The next thing we'll do is we will look at our significance level. So here we have a two-sided P of less than 0.001. So despite me looking at that and saying, well, it doesn't look that different, the reality is they are statistically significantly different from one another. Okay, so the question then is, how different are they? You move over to your t-statistic. Remember, your t-statistic is your mean differences divided by the standard error of the mean, and we end up with a negative 3.939. So using our two-sided P and our t-statistic, we can conclude that the mean differences, these two numbers, 143.44 and 146.89, are statistically significantly different. In other words, we reject our null hypothesis and we conclude that there is a significant difference between our sales after the event and our sales before the event. In other words, we sold significantly more units after our event took place.